Picture something that defies every boundary your mind has ever tried to draw. Something so colossal, so violently enormous, that the very laws of the cosmos seem to groan under the weight of its existence. Something that should not be real, and yet is indisputably, undeniably, terrifyingly real. This is TON 618, a monster from the abyss, a gravitational god sitting in the dark 10.4 billion light-years away, the single most massive black hole ever confirmed by human science. And right now, at this exact moment, as you watch these words unspool across your screen, something invisible, something ancient beyond all reckoning, is traveling from TON 618 directly toward Earth. That invisible messenger has been in transit for more than 10 billion years. In a very real and measurable sense, it has already arrived. And the only question that remains is whether we should be afraid. We will answer that. But first, we need to truly understand what TON 618 actually is, because almost everything the average person believes about black holes is wrong. Not slightly wrong, not approximately wrong. Fundamentally, structurally, embarrassingly wrong in ways that will change how you understand everything that follows in this video. Before we go any further, we need to demolish a myth so widespread, so deeply embedded in popular science communication, so thoroughly reinforced by decades of dramatic cinema and television that it distorts every other conversation we might have about objects like TON 618. Black holes are not cosmic vacuum cleaners. They do not reach across space and suck in everything around them. They do not prowl the galaxy, hoovering up planets and stars and civilizations at random. That image, the swirling drain in space, the irresistible vortex of doom pulling in everything within a vast radius, is a dramatic convenience that has almost nothing to do with actual gravitational physics. It is good for movie posters. It is terrible for understanding the universe. Here is the thought experiment that cuts through the nonsense. Imagine that our sun, right now, at this instant, was replaced by a black hole of identical mass. Not a larger black hole, not a more powerful one, the exact same mass compressed into a point. What would happen to Earth? Absolutely nothing, gravitationally speaking. Earth would continue tracing the exact same elliptical orbit it has always traced. Mars, Jupiter, Saturn, Uranus, Neptune, all of them would keep right on going, undisturbed, their orbital periods unchanged to within any measurable precision. The gravitational field outside the sun's surface is determined entirely by the total mass, not by how that mass is distributed. Replace the sun with a black hole of the same mass, and the gravitational field outside the original solar radius is identical to what it was before. We would, of course, freeze to death. Within weeks, surface temperatures would drop below -100 degrees Celsius. Within a year, the atmosphere itself would begin to liquefy and fall as rain. Every ecosystem would collapse. Every ocean would turn to ice. The photosynthesis that drives all complex life on this planet would cease. The entire biosphere, billions of years of evolutionary experimentation, every species that has ever lived, would die in the cold and dark. But from the perspective of orbital mechanics, nothing changes. That is the first and most important thing to understand. A black hole is not a special kind of gravity. It is just an extreme concentration of mass in an extremely small volume. And it is that concentration, that almost inconceivable density, that makes the region immediately around the black hole so lethal. As you approach the center, the gravitational gradient becomes so steep that the difference in gravitational pull between your head and your feet becomes meaningful, then severe, then fatal. This process has a name: spaghettification. Not a metaphor, an actual technical term used in astrophysics to describe the stretching of infalling matter into thin strands by differential tidal forces. At sufficient proximity, even light itself, moving at 299,792 kilometers per second, the absolute cosmic speed limit, cannot generate enough velocity to escape. It curves back inward. It falls. It is swallowed. The boundary where this happens has a name, the event horizon. But the word boundary is already slightly misleading because the event horizon is not a wall. It is not a surface you could feel or touch. It has no texture, no temperature, no physical presence you could detect with any instrument we possess. If you were somehow crossing it right now, you might not notice the moment of crossing at all, at least not immediately. What makes it profound is not what it feels like, but what it means. Cross that threshold, and the entire external universe, every star, every galaxy, every person you have ever loved, ceases to be a place you can return to. It becomes, in the most literal possible sense, your past, not your future, never your future again. There are two broad categories of black holes that astronomers work with most often. The first type, stellar mass black holes, are born when massive stars exhaust their nuclear fuel and collapse. Their cores implode under their own gravity. The outer layers rebound in a supernova explosion, briefly outshining entire galaxies. What remains is a black hole typically ranging from a few to a few dozen solar masses. These objects are violent and extreme by any everyday standard, but they are, in the grand cosmic accounting, relatively modest. There may be hundreds of millions of them scattered throughout the Milky Way alone. The second category is something else entirely. Supermassive black holes lurk at the centers of galaxies. Every large galaxy we have ever studied, and a great many smaller ones, appears to harbor one of these monsters at its core. Our own Milky Way galaxy has one. It is called Sagittarius A star, abbreviated SGRA star, and it was imaged directly for the first time in 2022 by the Event Horizon Telescope collaboration. An array of synchronized radio telescopes spread across multiple continents, functioning together as a single Earth-sized instrument. The mass of Sagittarius A star is approximately 4 million solar masses. 4 million suns, compressed into something smaller than the innermost orbit of our solar system. That sounds incomprehensible until you realize that by the standards of the objects we are about to discuss, Sagittarius A star is barely a warm-up act, a local curiosity, a rounding error in an accounting system that operates in entirely different units. Because then there is TON 618. The story of TON 618's discovery is itself a lesson in how profoundly science can mislead itself, and then, through the relentless accumulation of better data, correct itself. The year was 1957. At the Tonantzintla Observatory in the mountains of Mexico, astronomers were conducting a routine photographic survey of the sky. Glass plates coated in light-sensitive emulsion were being exposed to sections of the night sky, then developed, examined, and catalogued. It was painstaking, systematic, often deeply unglamorous work, the kind of careful, methodical labor that forms the invisible foundation of every spectacular discovery. And somewhere in the catalog, entry number 618, there appeared a faint blue dot. Nothing about that blue dot seemed remotely remarkable. The sky is absolutely full of faint blue dots. Most of them are ordinary stars. Some of them are interesting stars. A few are slightly unusual. But to the astronomers examining those glass plates in the late 1950s, this particular blue dot warranted no special attention. It was logged, catalogued, and effectively forgotten. The name it was eventually given, TON 618, from Tonantzintla Observatory, entry 618, reflects that original mundanity with almost comic precision. 15 years passed. By the early 1970s, astronomical instrumentation had advanced considerably. Spectrographs, instruments that split incoming light into its component wavelengths, revealing the chemical and physical fingerprints of distant objects, had become precise enough to analyze sources that would have been unanalyzable a decade earlier. And when astronomers turned these improved tools toward that faint blue dot from the 1957 catalog, what they found shattered the original classification entirely. This was not a star. The spectral signature was unlike anything produced by stellar nuclear fusion. There were emission lines, bright spectral features indicating specific atomic transitions. But they were in the wrong places. They were shifted, moved systematically toward the red end of the spectrum by an amount that indicated not ordinary stellar motion, but cosmological redshift, the stretching of light wavelengths caused by the expansion of the universe itself over the billions of years the light had been traveling. The numbers, when calculated, were almost impossible to accept. TON 618 was a quasar, a quasi-stellar object. The term quasar is a contraction of quasi-stellar radio source, though not all quasars emit strongly in radio wavelengths. A quasar is an active galactic nucleus, the central supermassive black hole of a distant galaxy, actively feeding on infalling material and radiating energy so intensely that the nucleus outshines the combined light of every star in the surrounding galaxy, not by a small margin, by factors of hundreds or thousands. And the distance? Just over 10.4 billion light years. Think about what that means. The light reaching our telescopes when we look at TON 618 departed from its source when the universe was less than 4 billion years old. Our sun would not form for another 6 billion years after that photon began its journey. Earth would not coalesce from the protoplanetary disk for another 6.5 billion years. Every atom in your body, the carbon in your cells, the oxygen in your blood, the iron in your hemoglobin, was billions of years away from being synthesized in the cores of stars that had not yet been born, in supernovae that had not yet exploded, scattered into clouds that had not yet collapsed. And yet those photons had already been traveling for 6 billion years before any of that began. When they finally reach our telescopes, as they do every night without exception, they deliver a message from an epoch so remote that the very word ancient seems inadequate. We need a different word. The English language does not quite have it. Now we arrive at the part of the story that transforms TON 618 from simply astonishing into something that genuinely strains the cognitive architecture of the human brain. Our sun is not a small star. It contains approximately 1.989 times 10 to the power of 30 kilograms of mass, enough volume to hold approximately 1.3 million Earths. By any human frame of reference, it is enormous. By the standards of the Milky Way, it is average. By the standards of the largest known stars, objects like UY Scuti or Stephenson 2-18, our sun is on the modest side. But none of that matters once you begin to understand TON 618. The mass of TON 618 is estimated at approximately 66 billion solar masses. Some more recent analyses, using updated calibration methods and revised spectroscopic measurements, suggest the true figure may be closer to 40 billion solar masses. But here is the brutal truth. The difference between 40 billion and 66 billion, while technically significant for the scientists doing the calculations, is psychologically irrelevant. Both numbers are so far beyond human intuition that neither one is comprehensible in the ordinary sense of that word. Both numbers place TON 618 in a category so far beyond ordinary supermassive black holes that astronomers were forced to invent new vocabulary to contain it. They called it ultramassive, not supermassive, ultramassive, a word that did not exist in professional astrophysics literature until objects like TON 618 demanded its existence. To put the scale in terms that might actually penetrate the brain's natural resistance to numbers this large, take every star visible to the naked eye from a truly dark site on a clear night, perhaps 6,000 to 8,000 of them. Take every star in every constellation you have ever learned the name of. Take the entire visible river of the Milky Way as it arches across a summer sky. Those hundreds of billions of points of light spread across 100,000 light-years of space. Take every stellar remnant, every neutron star, every white dwarf, every stellar mass black hole. Collect all of that mass, every gram of hydrogen and helium and carbon and iron and oxygen. Assemble it, weigh it. It still would not be enough to equal Ton 618. The entire stellar mass of our galaxy, one of the larger spiral galaxies in the observable universe, is outweighed by a single black hole in a galaxy we cannot even resolve into individual stars from here. The event horizon of this object, the spherical boundary beyond which nothing returns, has a radius of approximately 1,300 astronomical units. 1 astronomical unit is the distance from Earth to the Sun, roughly 150 million kilometers. Pluto orbits at roughly 39 to 49 astronomical units, depending on where it is in its elliptical orbit. Neptune, the farthest recognized planet, orbits at about 30 astronomical units. Ton 618's event horizon extends more than 30 times farther than the orbit of Pluto, in every direction simultaneously. Its full diameter, measured from edge to edge through the center, is approximately 2,600 astronomical units. You could fit dozens of complete solar systems inside that single measurement, laid end to end, and still have room left over. The fastest thing in the universe, a photon of light, traveling at 300,000 kilometers per second, would require approximately 2 weeks of uninterrupted travel to cross it from one side to the other. 2 weeks for light to cross a single black hole. Let that number exist in your mind for a moment without trying to minimize it. Now imagine, purely as a thought experiment, because the physical reality would kill you thousands of times over before you got anywhere near this boundary, that you were positioned at the edge of Ton 618's event horizon. The first thing you would notice is the sky, and it would be nothing like any sky you have ever seen. What you would see, if you could somehow survive to look, would be the most violent optical transformation in the known universe. The extreme curvature of spacetime produced by this much concentrated mass at this proximity would act as a gravitational lens of almost incomprehensible power. Every galaxy in the observable universe would be warped, compressed, bent, and smeared into thin arcs of light above you, like the entire cosmos being squeezed through a fisheye lens of infinite distortion. Stars that should be behind you would appear in front of you, bent around the curvature of space. The familiar patterns of constellations would be entirely gone, replaced by rings and arcs and smeared bands of light from sources spanning the entire history of the visible universe. And below you, in the direction of the black hole itself, there would be nothing. Not darkness in the way a cloudy night is dark. Not even the darkness of intergalactic space, which contains at least a few stray photons per cubic meter. What lay in the direction of the event horizon would be a perfect circle of absolute absence. Not a surface, not a texture, not a thing you could point at and say, there it is. Simply nothing. An absence so geometrically perfect and so complete that your visual cortex would have no category for it, would refuse to process it as a shape or a void, would sit in a kind of perpetual confusion, trying to interpret the end of all information as an object. It would be the most alien visual experience in the universe, and your watch would be lying to you. Time dilation near an object of this mass would be severe by any measurement. The mathematics of general relativity, tested in GPS satellites, confirmed in atomic clock experiments, used to calculate the inspiral and merger of black holes detected by LIGO, tell us that time itself passes more slowly in stronger gravitational fields. It is not a metaphor. It is not a perception. It is a measurable, real, physical asymmetry in the rate at which time passes in different gravitational environments. Close enough to TON 618, a single subjective hour of your experience could correspond to decades of time passing for observers far away. A single day might consume centuries. The people you left behind would grow old and die while you experienced a mourning. You would return, if such a return were even theoretically possible, to a world that had moved on by generations, by civilizations, by geological epochs. The language spoken would be different. The cities you knew would be ruins or memories. The stars would have drifted slightly in their courses, and you would have aged by a single day. Here is where the description of TON 618 shifts from extraordinary to genuinely staggering. TON 618 is not a dormant black hole. It is not a passive gravitational monument sitting in quiet darkness. It is an active quasar, which means it is feeding. It is consuming matter on a scale that makes every other energetic process in the observable universe look modest by comparison. Around TON 618, there is an accretion disk, a vast, rotating, catastrophically hot structure of gas, dust, and stellar debris captured by the black hole's gravity and spiraling inward toward the event horizon. Before that material crosses the point of no return, it is compressed and heated by friction, by the energy released when adjacent layers of infalling material, moving at slightly different velocities, collide and grind against each other. The temperatures involved are not thousands of degrees, not millions of degrees, as you would find in the outer corona of a star. The inner regions of an accretion disk around a black hole like TON 618 reach temperatures in the hundreds of millions to billions of degrees. This is hotter than the interiors of most stars, hotter than most supernova shockwaves. Matter at these temperatures does not behave like anything we encounter in daily life, or in most of what we call extreme physics. It radiates across every wavelength of the electromagnetic spectrum simultaneously. That accretion disk around TON 618 would span light weeks in all directions. The disk of doomed material circling this single object is larger than the distance light travels in weeks of uninterrupted travel through vacuum. The luminosity this generates, the sheer light output, is estimated at approximately 140 trillion times the luminosity of our Sun. 140 trillion solar luminosities. If you place the entire Milky Way galaxy next to TON 618 during one of its active feeding phases, the quasar would outshine our entire galaxy, with its 200 to 400 billion stars, by a factor of several thousand. A single object, brighter than thousands of entire galaxies combined. That is how we found it. That is why a faint blue dot on a glass photographic plate from 1957 eventually resolved, after 15 years and vastly improved instrumentation, into one of the most staggering objects ever catalogued by human science. The photons that carried that signal had traveled for more than 10 billion years, had their wavelengths stretched enormously by the expansion of the universe, had survived the crossing of a vast and hostile cosmos, and still arrived energetic enough to be detected and analyzed. Stars that venture too close to TON 618 do not simply fall in whole. They are destroyed first. The tidal forces, the differential gravitational pull between the near side and the far side of an approaching stellar body, become so extreme that they overcome the star's own structural integrity before it ever reaches the event horizon. The star is stretched, elongated, disrupted, and eventually torn apart in what astronomers call a tidal disruption event. Streams of stellar material spiral inward, heating to extreme temperatures, generating enormous pulses of ultraviolet and X-ray radiation. These events have been observed around smaller black holes, brief, violent flares recorded by orbiting telescopes, each one marking the death of a star. Around TON 618, entire stellar clusters could be consumed within a single human lifetime. The quasar would barely register the addition to its diet. Its appetite is calibrated not to individual stars, but to galactic-scale structures. Here is the mystery that elevates TON 618 from spectacular to scientifically alarming. The problem that has been generating papers and arguments and late nights at whiteboards for 2 decades. Black holes grow in 2 ways, by accreting surrounding matter and by merging with other black holes. Both processes have known speed limits. The Eddington limit defines the theoretical maximum rate at which a black hole can accrete matter before the radiation pressure from the infalling material becomes strong enough to push new material away, throttling the feeding process. At the Eddington limit, a black hole doubles its mass roughly every few tens of millions of years. Now run the mathematics backward from TON 618's mass of 66 billion solar masses. Start with the largest plausible stellar remnant seed, perhaps a few hundred solar masses, formed from one of the first generation of massive stars in the universe. Allow it to accrete at the Eddington limit continuously, without pause, from the earliest possible moment. The very first few 100 million years after the Big Bang, when the first stars began forming. Does the math work? It does not. It does not come close. Simple calculations show you cannot reach 66 billion solar masses, or even 40 billion, starting from a stellar remnant seed within the available time, even at maximum theoretical accretion rates. The universe was less than 4 billion years old when TON 618 reached its observed mass. There is simply not enough time in the standard model of black hole formation to explain it. 3 hypotheses have emerged to address this paradox. The first is direct collapse. In the very early universe, before the first stars had formed, enormous clouds of primordial hydrogen and helium gas may have been able to collapse, not into stars, but directly into massive black holes, bypassing the normal stellar formation process entirely. These direct collapse black holes could have formed with initial masses of tens of thousands to hundreds of thousands of solar masses, giving them a colossal head start on any stellar remnant seed. Starting from that enormous foundation, with subsequent accretion, reaching ultramassive scales becomes at least plausible within the available time. The second hypothesis involves runaway mergers. In the densely packed centers of early galaxies, massive stars and young black holes may have been colliding and merging at an extraordinary rate, a kind of gravitational chaos in the heart of a young galaxy, where the biggest objects kept consuming smaller objects in rapid succession. Each merger pushed the central object into a new mass regime. If this process happened fast enough and repeatedly enough, something approaching TON 618's mass could accumulate within the available time. The third and most speculative hypothesis involves primordial black holes, objects that formed not from stellar collapse, but from density fluctuations in the very early universe, in the first fractions of a second after the Big Bang. Primordial black holes would have had the maximum possible head start. They would have been growing from the very beginning of cosmic time, potentially accumulating mass for hundreds of millions of years before the first stars lit up. If they exist, they change the accounting entirely. We do not know which of these hypotheses is correct. We may never achieve certainty. But what we know with complete confidence is this: our existing models of black hole formation and growth are insufficient to explain what we observe. The early universe was building things bigger and faster than our equations say was possible. TON 618 is the most extreme confirmed proof of that insufficiency, but it is not the only one. The James Webb Space Telescope has been simultaneously the greatest astronomical achievement of the 2020s and the source of the most persistent headaches for cosmological theorists. Since its first scientific observations in 2022, Webb has been peering deeper into the universe's past than any instrument before it. Its infrared sensitivity allows it to observe the light from the earliest galaxies. Photons so redshifted by billions of years of cosmic expansion that they have been stretched entirely out of the visible range and into the infrared. And what Webb has been finding, repeatedly and with accumulating confidence, are what astronomers have taken to calling little red dots. These little red dots are compact, reddish sources of light in the very early universe. Galaxies and active galactic nuclei existing just a few 100 million years after the Big Bang. Many of them appear to harbor supermassive black holes already containing hundreds of millions or even billions of solar masses in a universe that was, at that epoch, only a tiny fraction of its current age. Every theoretical model that existed before Webb told us that black holes of this size, in galaxies this young, should not exist. The universe had not had enough time, enough matter concentration, enough of any of the ingredients our models said were necessary. The galaxies themselves appear more massive, more structured, more chemically evolved than our simulations said they should be at those epochs. And yet there they are, staring back at us from the infrared, demanding explanations we do not yet have. Each new Webb observation is not just an interesting data point. It is a challenge to the entire theoretical framework that cosmologists have been building, refining, and defending for decades. The models are not being overthrown. Science proceeds by revision, not revolution. But they are being forced to accommodate realities they did not predict. That is both the glory of empirical science and the particular discomfort of being the generation of scientists whose models are currently being dismantled and reassembled. TON 618, in this context, is not an anomaly. It is the most extreme confirmed member of a class that turns out to be far more common and far more extreme than anyone expected. The monsters have company, and the company is everywhere we look. Now we return to the question that opened this video, the one you have been carrying since the first lines. Is TON 618 moving toward Earth? Are we in danger? The answer has two parts, and both matter. The first part, the object itself is not approaching, it is receding. The expansion of the universe, the same expansion that stretches the light from distant galaxies toward the red end of the spectrum, the same expansion that Edwin Hubble first quantified in the 1920s, and that cosmologists have been measuring with increasing precision ever since, is carrying TON 618 away from us at a rate that, at those distances, exceeds the speed of light. Not because anything is physically moving through space faster than light, but because space itself is expanding. The metric expansion of spacetime adds distance between every pair of points in the universe that are not gravitationally bound to each other, and it adds it at a rate that, for objects at the distance of TON 618, is genuinely superluminal. The distance between us and TON 618 is increasing right now. It will increase while you sleep tonight. It will continue increasing for every remaining moment of human history and far beyond. TON 618 will never reach us. Its gravity, diluted by those billions of light years, exerts absolutely zero measurable influence on anything in our solar system. The gravitational pull of TON 618 on Earth is not dangerous. It is not detectable. It is, in all practical physical senses, non-existent. And yet, the second part of the answer is stranger and more beautiful than any physical threat could be. When you look at TON 618 through a telescope, when any observer turns an instrument toward that patch of sky, you are not seeing TON 618 as it is now. You are seeing it as it was 10.4 billion years ago. You are receiving ancient light, antique photons, particles of electromagnetic radiation that departed their source before our sun existed, before Earth existed, before any of the geological or biological history of this planet had begun. Those photons have been traveling for over 10 billion years. They have crossed an expanding universe, threading their way between galaxy clusters and through vast intergalactic voids, losing energy to the cosmic expansion, arriving redshifted, but still arriving, every night. The fraction that survived the crossing is vanishingly small compared to what was emitted. But the absolute number arriving per night at our telescopes is still scientifically useful. Right now, ancient light from TON 618 is striking the primary mirrors of telescopes in Chile's Atacama Desert, on Mauna Kea in Hawaii, on the Peak of La Palma in the Canary Islands, and at sites in Arizona. It is being focused and analyzed and converted into data. And every time this happens, every time one of those 10-billion-year-old photons completes its journey and deposits its tiny quantum of energy in a detector, information is recovered from an epoch so remote that it is almost beyond conceptualization. That is what is moving toward us from TON 618. Not the object, not its gravity, not any threat, light, information, the most ancient message we are currently capable of receiving. Every photon that completes that 10-billion-year journey is carrying the same fundamental payload of information. And when you assemble and analyze that information, when you extract the spectrum, measure the luminosity, calculate the distance, infer the mass, you are confronted by facts that are deeply uncomfortable for anyone who has invested confidence in our current cosmological models. The message says, the universe was building things bigger and faster than your equations say should have been possible. The message says, the mechanisms you have identified for black hole growth are either incomplete or wrong, or both, and you do not yet know which. The message says, there is a chapter in the early history of the cosmos that your physics has not yet successfully described. This is not cause for despair. It is, if anything, the best possible news a scientific community can receive. Clear, high-quality evidence that the universe is stranger and richer than previously understood. Every major revision to our understanding of reality has historically opened new doors, new predictions, new capabilities, new questions worth spending careers on. The incompleteness of our current models is not a failure. It is an invitation. But it is also a humbling thing to sit with quietly. We are a species that has walked on the moon 12 times. We have dispatched robotic emissaries to every planet in our solar system. Rovers that have driven across Mars, measured wind speeds on Venus, sampled the atmosphere of Jupiter, photographed the rings of Saturn up close. The Voyager 1 probe, launched in 1977, and now the farthest human-made object in existence, is crossing through interstellar space, carrying a golden record of human sounds and music and greetings in 55 languages. Our gravitational wave detectors can sense a distortion in the fabric of spacetime, caused by the merger of two black holes more than 1 billion light-years away, that is smaller than a proton. By any historical standard, we are extraordinarily sophisticated observers of nature, and we are staring at an object whose existence our best theories cannot fully explain. The ancient light from TON 618 is not just data, it is a mirror, and what it reflects back at us is the precise outline of our own collective ignorance. There is one final comparison worth making, one last attempt to translate the scale of TON 618 into something emotionally, not just mathematically, legible. Go somewhere dark, far from city lights, far from ambient glow. Let your eyes adapt for 20 minutes. Then look up at the Milky Way, that faint, luminous band arching across the sky, the combined light of hundreds of billions of unresolvable stars, the structure that contains our entire astronomical history. Every observation ever made of the night sky was made from inside that structure. Every civilization that ever rose and fell on this planet rose and fell inside that galaxy. The Milky Way is, by any ordinary human standard, incomprehensibly large. TON 618, the black hole, the single gravitational singularity at the center of a galaxy 10.4 billion light-years away, has a mass that exceeds the combined stellar mass of the entire Milky Way. Every star in our galaxy, every red dwarf burning dim and slow, every brilliant blue giant burning hot and fast, every white dwarf cooling in the dark, every neutron star spinning with the remnant angular momentum of a collapsed stellar core, their combined mass is less than what TON 618 has compressed into a single mathematical point. That point is transmitting its ancient light across the cosmos. It reaches our telescopes tonight. It will reach them tomorrow. It will continue to reach them for as long as there are functioning instruments and curious minds to interpret the signal. TON 618 poses no physical threat to Earth. This needs to be stated clearly and without equivocation. You are not in danger from this object. Neither are your children, or their children, or any generation of humanity across any timescale relevant to biology or civilization, or even the geological history of this planet. The expanding universe is carrying TON 618 irreversibly away from us. Its gravitational influence on our solar system is too small to measure. Its radiation, after 10 billion years of travel through expanding space, arrives at intensities that are harmless by every possible metric. But the kind of fear TON 618 inspires, or should inspire, is not the fear of physical danger. It is the vertigo of scale. The particular cognitive and emotional unsettling that comes not from a threat, but from a sudden, brutal revision of one's sense of where we stand in the hierarchy of things. The rules of physics work beautifully at human scales and at solar system scales, and even at galactic scales. General relativity predicts the orbit of Mercury, the bending of light around the sun, the slowing of clocks in gravitational fields, the existence and properties of gravitational waves, all confirmed by observation. These are among the greatest intellectual achievements in human history. But at the edges of the observable universe, in the first few billion years after the Big Bang, something was happening that our equations were not built to describe. The universe in its youth was assembling structures, vast, violent, gravitationally catastrophic structures, at speeds our models say were impossible. And we know this only because of a faint blue dot on a glass plate from a Mexican observatory in 1957. A dot that sat in a catalog for 15 years before anyone understood what they were looking at. How many more such dots are waiting, in old data archives, in unstudied spectra, in the vast backlog accumulating from sky surveys that generate more raw data in a single night than previous generations of astronomers could have processed in a lifetime? Almost certainly, there are larger monsters waiting to be found. TON 618 holds its record, the most massive confirmed black hole known to science. But records in science are almost always temporary. The history of astronomy is an unbroken sequence of each generation discovering that the universe is larger, older, stranger, and more extreme than the generation before believed. There is no sign that pattern is ending with us. Somewhere in the universe right now, in light that has not yet reached our telescopes, in observations not yet made, in data not yet analyzed, there is almost certainly something bigger, something that will demand yet another new word, something that will generate the same productive intellectual crisis that TON 618 has been delivering to cosmologists for half a century. And every photon from every one of those objects is already in transit, already crossing the void, already heading toward whatever instrument will one day catch it. The messages are coming. They have been coming for billions of years. We are only now, in the briefest and most recent sliver of cosmic time, learning how to listen. That is the universe we inhabit, not a stable, comprehensible backdrop to human drama, not a predictable system operating within known bounds, a place that, at its most extreme scales, was building engines of annihilation of almost incomprehensible magnitude before our planet existed, and has been sending us evidence of that fact ever since, in the form of ancient light traveling for billions of years to rest in the mirrors of our telescopes on remote mountain peaks, illuminating the borders of what we know and the vastness of what we don't. Every night, TON 618 speaks, and every night the message is the same. You do not yet understand what we are. You do not yet know how large we can become. You do not yet see how much of existence remains hidden from you in the dark, at distances your mathematics is still learning how to describe. That message is not a threat. It is something stranger and more enduring than a threat. It is the universe reminding us, as it has always reminded us, through every discovery from Copernicus to Hubble to the Event Horizon Telescope, that curiosity is the only appropriate response to a cosmos this large, this violent, this ancient, and this utterly, magnificently beyond us. The void is not empty. The dark is full of things we have not yet named, and somewhere, 10.4 billion light years away, something inconceivably massive sits in the silence, feeding, growing, and transmitting its light toward a small rocky planet where fragile, inquisitive creatures are just beginning to learn how to listen. If you enjoyed this journey into the most extreme corners of the known universe, if this video left you staring at the ceiling, wondering what else is out there in the dark, then hit the like button. It takes 1 second and it means everything for getting this content to more curious minds. Subscribe to the channel so you never miss our next expedition into the deepest, most extraordinary places in existence. And leave a comment below. Does the scale of TON 618 fill you with wonder or with dread? Or, as it should, with both? Until next time, keep looking up.